Hello and welcome to this video, and we are going to get into the specifics of graphing rational functions and all of the different things that you have to think about. So the first thing you always want to do is get the function into factored form if it's not already in factored form. In this particular function, the top is a difference of two squares, so you can factor that to x plus 4, x minus 4. And the bottom is a trinomial that you can factor to x minus 3, x minus 4. Okay? Step 2 is you want to think about all of your domain restrictions. Now this is something we've already been working on in Module 1 and Module 2, so this should seem familiar to you. And we know that in a rational function, the denominator cannot be equal to 0. So that means we must think about each of these factors that are on the bottom, and we must think about what value could create a 0. And in this case, if you had a 3, you would have a 0, and if you had a 4, you would have a 0. Excuse me. So those are both domain restrictions, and we'll write that in interval notation. Okay, indicating that our domain can be anything from negative infinity to 3, union 3 to 4, union 4 to infinity. Okay, now the next thing we're going to look at is discontinuities, which are breaks in the graph. A discontinuity can be a hole or a vertical asymptote. Both of those will create a break in your graph. For this first part here with the holes, we want to look for factors that repeat in the numerator and the denominator. Okay, so if we go back up here and we look at our function, we can see that we have a factor in the top of x minus 4, and that matches a factor in the bottom of x minus 4. So that factor is repeating in the top and the bottom. Okay, so continuing on through this here, it says the factor x minus 4 will give us a whole. Okay, and that means that the x value of 4, okay, that will be the x value of the point that is a whole. Okay, excuse me. So if you just think about x minus 4 equal to 0, x equals 4, that's kind of going to give you that x value of the whole. All right, now we always want to write our whole as a point, an xy point. So at this point we know that the x value of the point is 4, okay, but we still need to find the y value. So if we go back up and we look at the function f of x, okay, I'm actually just going to copy that over down here. Our function is x plus 4 times x minus 4, and then x minus 3 times x minus 4. Okay, what you do is you cancel out, you think of canceling out the factor that repeats on the top and the bottom. So that's going to be the x minus 4. All right, and then you plug in a value of 4 into the function that's remaining. So this is the part here, right, that's still remaining. So I'm going to have 4 plus 4 on the top, and then 4 minus 3 on the bottom, and that's 8 over 1, which is 8. So that gives me that second part of the point. Okay, I'm going to have a whole that is the point 4, 8. All right. Now if you look at this next section here, this is your vertical asymptotes. So you want to look for factors in the denominator that do not repeat in the numerator. So if you go back to your function, okay, and I'll change to a different color here. We'll go green. All right, this is your factor in the denominator that is not repeating in the numerator. So it's basically going to be any other factors that are in the denominator that you didn't already use with the whole. Okay, so the x minus 3 was still left there, so that's what we're going to use for our vertical asymptote. And so, whoops, let me change back to the pen. Okay, so the factor x minus 3 will give us a vertical asymptote, and that means the x value of 3 will represent a vertical line that is the vertical asymptote. And we always write lines as an equation, so you will say x equals 3. Okay? And right here you can just kind of think about what we did before, is kind of think about setting that equal to 0 and solving that. Okay? All right, so now we need to think about our horizontal asymptote, which actually we could also have what we call a slant asymptote here as well. Okay, so there's 3 different cases that you have to think about. There's case 1, case 2, and case 3. It all depends on the degree of the numerator and the denominator. So for case 1, if the degree of the numerator is the same as the degree of the denominator, then what you do is you divide your leading coefficients. Divide leading coefficients. And that will give you your horizontal asymptote. All right. If, okay, you have case 2 where the degree of the numerator is lower than the degree of the denominator, okay, then your horizontal asymptote will be y equals 0. Okay, that's actually kind of an easy one because there's no calculating involved. It's just going to be y equals 0, which is actually just right on top of the x-axis, right? Now, if you have case 3, that's when the degree of the numerator is greater than the degree of the denominator. And we're going to specifically talk about when there's a difference of 1, okay? There are other scenarios that can happen, but we don't really get into that stuff in this particular class. You'll probably see that later down the road as you progress in your other math classes. So if for this class, if you have the numerator, the degree of the numerator is greater than the degree of the denominator by 1, okay, then what we have is a slant asymptote. Okay, now if you need to find the actual slant asymptote, you know, the actual equation of that line, then we use polynomial long division. Okay, so that's that division that we used previously in a previous lesson. It's coming back and it's going to help us with some other things here. And we actually will discuss more about slant asymptotes in a future lesson. Okay, but we will discuss that. So for f of x, okay, the degree of our numerator is 2 and the degree of the denominator is 2. Now let's go back up and review that real quick. I know some students have had some confusion about that. When you are looking at this original function, how it was presented, your highest exponent was 2. All right, and that is the degree, okay? So they both had a 2 on the top and the bottom, so the degree of the numerator is 2 and the degree of the denominator is 2. If your function is in factored form, okay, remember that you add up those exponents. So think about, you have exponents of 1, so 1 plus 1 is 2, 1 plus 1 is 2. So either way you think about it, the degree of the numerator is 2 and the degree of the denominator is 2. I just wanted to review that because that's going to be very important that you are calculating the correct degree. Okay, so for f of x, the degree of the numerator is 2 and the degree of the denominator is 2, which means we have case number 1. Okay, because whenever the degree is the same on the top as the bottom, then that is case 1. And our horizontal asymptote is going to be y equals 1. And what we're doing there is we're dividing our leading coefficients. So I'm going to take leading coefficient of the top and divide it by the leading coefficient of the bottom. Okay, well, let's go back up to our function here. Our leading coefficient is the number out front here, right? So that's 1 and that's 1. So our leading coefficients are 1 and 1. So we go back down here to our calculation and we are doing 1 divided by 1 and 1 divided by 1 is 1, and this result that we get here is what you put in for that horizontal asymptote. Okay. All right, so step 5, we're going to find our y-intercept, and you find the y-intercept by plugging in a 0 into the function. Okay, and you can use either the original form of the function where they had the x squared minus 16 over the, let's see, what was it, x squared minus 7x plus 12. You can plug in a 0 to that. Or if you prefer, you can plug in a 0 to the factored form. And either one's okay because they're both going to give you the same result, okay? Personally, I like plugging into this version because it's pretty easy to see how things are going to zero out. You're going to have 0 squared minus 16 over 0 squared minus 7 times 0 plus 12. So you can pretty easily see you're going to get negative 16 over 12, which is negative 4/3. And then make sure you write that as an xy point. So the y-intercept is 0, negative 4/3. All right, so moving down to step 6, we're going to find our x-intercepts. Okay, well technically you're setting your function equal to 0 and solving, but there's a little trick that you can use here that students like a lot, and that's the factors. You can look at the factors in your numerator, okay, that were not involved in a whole. These will always give you x-intercepts, okay? So if you look back to our factored version of the function, we had the x minus 4s. Those were involved in the whole, so we're not going to worry about that. And so this is the other factor in the numerator, okay? And since that was not involved in a whole, we can use that to find our x-intercept, okay? So we say x plus 4 equals 0, and x equals negative 4. And that will be an x-intercept. So we'll write that as an xy point. All right, so step 7 is where we're going to put all this information together. Okay, so let's actually just list it all out here. We had a vertical asymptote of x equals 3. We had a horizontal asymptote y equals 1. We had a y-intercept of, let's see, what was that? 0, negative 4/3. We had an x-intercept of negative 4, 0. We had a whole of 4, 8. All right, and that was all of the information we've already found. Okay, so let's go ahead and sketch a graph here. So I like to plot my asymptotes first. So I have a vertical asymptote at x equals 3. Okay, so you can see that vertical line there. And I have a horizontal asymptote at y equals 1. Okay, so you can see that horizontal line there. I have a y-intercept of negative 4/3, so it'll be down a little past negative 1 there. I have an x-intercept of negative 4. Okay, and I have a whole of 4, 8. So make sure you make that an open circle, because remember that's a whole, and so you don't want to plot it like a regular point. Make it an open point. Okay, so you can definitely see that something's happening down here. Okay, you have 2 points down here in this bottom left, right? And we can kind of imagine the curve there. So obviously you want to connect these 2 points, kind of make it into a curve, and then you want to head towards the left there. Okay, and then you want to head down south here. Okay, and we just want you to sketch, so you don't have to be super perfect. Okay, we just want to see the general look there. You're going through those points and you have the correct end behavior. Okay, now up here we do need a little bit more information. We have a hole up there, but I mean, you don't want to get too loose with your drawing, okay? So you need to find a couple of more points, and so that's why you're going to do a quick little XY table. And the hole was using an x value of 4, so maybe if we use an x value of 5 and 6. Okay, that would give us a couple of good points. I've already done that calculating, and all you're doing is plugging in a 5 and seeing what you get. You get 4.5. And then when I plugged in a 6, I got 3.3333. Okay, repeating. So let's sketch those points real quick. So if I go over to 5, about 4.5, somewhere in there, and then 6, 3.33, something like that. You can kind of see that curve forming, and now you want to fill that in. So you want to jump over that hole there, make it curved, okay, make it have a little bend to it, and then you want it heading to the right, okay, and then you want it heading up there. So you want those asymptotes to steer that graph for you, okay. And then the nice thing you can always do is jump over to Desmos and look at the graph. So I think I have that in here now. And so Desmos will not graph the asymptotes for you. I just added those in just to kind of help you see the full graph. Desmos is just going to give you the curves, okay? Also, I want to point out that Desmos does not show that hole when you just glance at it. But now if I click on this curve and I go and I try to find that hole, okay, you can see right there it says 4, then undefined. So it knows something weird is happening there on the graph, but it does not always give you that full coordinate point. So you're going to have to do some calculating there on your own, and then you can use Desmos to check your work, okay? But basically what you're always doing is you're going to follow these steps, okay, the steps 1 through 7 that we discussed, and once you find all of this information, you will see that you have enough to get you started, and then you find more points as necessary. Okay. Good luck, and I'll see you in the next video.